Alright, in this video we are going to identify and determine the degree of polynomials. Example 1 says to rewrite the polynomial. So we have to write 7 plus 2x to the fourth minus 4x so that the exponents decrease from left to right. That's very important that we have our exponents decrease from left to right. Afterwards, we have to identify the degree and the leading coefficient of the polynomial. Alright, so the first thing I'm going to do is I'm going to rewrite the polynomial. 7 plus 2x to the fourth and minus 4x. Okay, so when I rewrite my polynomials so that my exponents decrease from left to right, I'm looking at the exponents for the variables of each term. These are all called terms, 1, 2, and 3. So this polynomial has 3 terms. Okay, so if you look at the 7, there is no x by it, but we're going to put one in there and show that if there was a variable without changing the value, the 7 would have an x to the 0 power. Okay, so now let's go with the term with the highest exponent, or the greatest exponent, 2x to the fourth. Okay, that would be the first term that you would write down. Next, well, if you look at the negative 4x, that's being raised to the first power, the x's. So that would be my next term in my polynomial. So I have 2x to the fourth minus 4x. And then finally, I'm left with the 7x to the 0. And because the x is being raised to the 0, that would be the smallest value of our exponents. So I would just write down plus 7. Okay? Because this has no variable along with it, we call this term right here a constant. So this would be my polynomial written from left to right. Alright, so now we have to identify the degree and the leading coefficient of polynomial. So now that we have our polynomial written from left to right that decreases in our exponents decrease from left to right, we would describe the degree as a fourth degree. Okay? So then after that, we have to identify the leading coefficient. Well, the coefficients are the numbers that are in front of the variables. So this is just considered a constant, but if it actually had a variable with it, the coefficient would be 7, coefficient's 2, and the coefficient of x would be negative 4. So then the leading coefficient would be 2. Alright, you try this on your own. Okay? Each polynomial needs to be rewritten with the coefficients, I'm sorry, not the coefficients, but the exponents decreasing from left to right, and then identify the degree and the leading coefficient of each polynomial. So pause the video and then try these on your own, then check back in with me for the answers. Okay, did you guys get these right? If so, good job. If not, mark your answers or whatever ones you got wrong, and then so that you can keep in mind that these were the ones that you had trouble with. Alright, so you have a chart. It's a you try now, but I will also explain if each expression is a polynomial degree and then identifying the number of terms we have. Okay, so if you'd like to pause the video and then try these on your own, and then check back in with the explanation afterwards. Alright, for A, is it a polynomial? Absolutely. Remember, if it's just a number, it's called a constant, but then the variable with it would be raised to the 0 power. So this would have a 0 degree polynomial, and the number of terms is 1, so we call that a monomial. Alright, the next example, B, m to the negative third plus 4. Is it a polynomial? Absolutely not. You cannot have a negative exponent in your expression. So we don't even have to fill in the next 2 boxes. Alright, negative h to the third plus 4h squared. Is it a polynomial? Yes. The degree, we're checking to see if it's written from left to right with decreasing exponents, 3, 2. So we say it's a third, and because there are two terms, 1, 2, we call it a binomial. Alright, for D, 9 minus 5x to the fourth plus 3x, is it a polynomial? Absolutely. And the degree, well, be careful because this is not written from left to right where the exponents decrease. So the highest degree would be to the fourth. And because there are 1, 2, 3 terms in this expression, we call it a trinomial. Okay? And then for E, we have 2w to the third power plus 4w. Is it a polynomial? Absolutely. And it is being raised to the third power, the highest degree. And since there are two terms, we call it a binomial. Alright, this next one is not on your chart, but I want you to add it in. We have f, and I want you to write down 3x to the fifth minus 2x to the t. Now, is this example, this new one, a polynomial? Well, we have 3x to the fifth minus 2x to the t, but because this x is being raised to another variable, we cannot say it is a polynomial. You cannot have a variable as an exponent for it to be a polynomial. So we don't even have to fill in the next two parts of the chart.